seen a month ago or anything like that. What's happening here is that we're going to talk about ratios of sides, ratios of scale factor, and so on and so on. So about a month ago, we talked about the ratio of sides of similar figures. They had the same ratio, it was A to B. Then they had what we called that was the scale factor. We called that the scale factor, A to B. Those two were always the same. The ratios of the sides and the scale factor were always identical. From that, we then did, hey, the ratios of the areas were always in the format then. Oops, area ratios were in the format of A squared to B squared. And what you did is that you just took the scale factor and you squared it. Okay? And if you had the area of the ratios, you took the square root of it to get the scale factor. Going forward, coming backward. Well, today we're going to throw in volumes. Volume ratios is just A cubed over B cubed. Okay. Put in the electronics. Take paper out, put your stuff on the ground. We're going to keep doing that from here from now on. I think you folks would appreciate that too. Okay. So you've got your areas. A squared to B squared, your volumes, A cubed, B cubed. So if you've got a scale factor and you have to go to area, what do? Square it. If you have a scale factor and you got to go to volumes, you cube it. Well, if you have areas and you have to go to scale factor, you square root. And if you have volume going to here, you cube root. That's really the gist of what we're looking at today. Going forward and coming back. Okay? That's what it looks like. You start with your scale factor, if that's what you have. You square it, or you cube it to go forward. If you start with a volume, you cube root it to go to the scale factor. Square it then to go to the area. It's just a matter of reading the questions correctly to go back and forth. Okay? For example, if, let's see here, and don't draw up this picture because that's kind of silly. If I have two pyramids, oops, whoa. If I have two pyramids, the volume of one pyramid P is 1,000. Cubic inches, and the volume of pyramid Q is 216 cubic inches. I can take that information to figure out both the scale factor and the ratio of their areas. Okay? And the idea here is whenever you get these problems is to always start with which of the three are you being given? Am I being given scale factor, area, or volume in this problem? Volume. So what I do is I know that I'm being given volume because it says the word volume. Convenient. So I write down A cubed to B cubed, and I fill in the blanks. 1,000 to 216. Yeah, but now I need to get to A to B. What do I do to that to go to A to B? Cube root. So in your calculator, this becomes a couple of buttons that you've just started using. Remember, to get the cube root symbol, we typed in 3-second caret. And then I can put in the fraction bar by just hitting the regular old fraction bar button. Fill in the blanks. And guess what you press now? And there's the ratio of there's your scale factor. So now you've got your scale factor happens to equal 5 to 3, which means what do I do to that to figure out the area ratio? Exactly. I just squared that. 25 to 9. Yes, ma'am. You need to know them, yeah. And remember, it's pretty easy. I mean, once you write it out once you say, oh, I have to go from 3 to nothing, I have to cube root from here to here, I squared, you'll get through some of that. Oh, did you need it off the screen? Or minimized? I wouldn't be me if I didn't do that. That is very true. Okay. You don't get this kind of, well, wait, you probably do get this kind of harassment in some of the classes. But you don't get this kind of harassment with a smile. It's true. You're probably right. You all right? Parlez-vous français? Oui. I'm just going left to right. And if you keep it consistent going left to right, you're fine. And that's usually how we set these things. For example, if I go into a, one of the things we'll be able to do is where we're going to be given the scale factor going from A to B, and you'll be given the surface area and the volume of one, find the surface area and the volume of the other. Very, 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 I hate to use the word similar, but it's similar to exactly what you did about a month ago. We did ratios of similar figures with just areas. This stuff doesn't change. The only thing that might be a little bit weird is that sometimes they use just S for surface area versus SA. This area that I'm writing here stands for surface area, of a three-dimensional shape, or just the regular old boring area of a square if you had to be a two-dimensional shape. That area ratio doesn't, it still works the same, the A squared to B squared. That doesn't change at all. So if I have a scale factor going from A to B is 2 to 3, that means the A to B fraction is 2 to 3. If my A to B is 2 to 3, that means my areas will be A squared to B squared, which means 2 to 3 has to get squared. So it's real tough now. 2 squared. 3 squared. So A squared to B squared is 4/9. That also means that it has to be cubed. Do you know what 2 cubed is off the top of your head? 8. Remember, it's 2 times 2 times 2. And then B cubed. We're going to 27. So here's your surface area. Here's your volume. These are given to you as A to B. We need to figure out the B surface area. So we have 90 pi over something. And this one would have been 100 pi over something else. And notice it is nothing more than a cross multiply and solve problem. How many times have we seen cross multiply and solve second semester? I was going to say at least twice, maybe 74, 75 times, maybe, ish. I know it's been more than twice. You're right on that one. I'll give you that. So when you cross multiply and solve, this becomes really, really quick. Now, last hour they were asking, do you have to keep it in terms of pi, or can you give the decimal? Yes. The answer is yes. You can do either one. What I would probably do, because it's less work, is just cross multiply and press enter, because you take the decimal. It's fine. It's okay. It's still the surface area. So when you cross multiply that first one, you're going to get 4x 810 pi. Divide that out, and I believe it's, I want to say 636.17. And then it's something squared because it's an area. You all right, John? Do the same thing with the other one. Cross multiply out, you get 2700 pi equals 8y. So we divide that by 8. 2700 pi over 8. Yeah, you would definitely overeat if you ate 2700 pies. Somebody was listening. Thank you. What do you get on that one? It was like 1060? About time to get here. What? How you go? Where they're at? What? Was it 1060? 1060 point something? I'm trying to remember what it was. 28, thank you. And then remember, it's something cubed. Okay, you're right. That's fine. Okay, and it's something cubed because you're talking about a volume, right? What's up? I forgot what the units were off the top of my head. I just was doing it in the middle of the problem. I forgot what it was. And I figured it's okay if you write units squared, units cubed, because at least you label. Okay. Let's try another. You guys do this one. You've got a scale factor of 1 to 4, going from A to B. You're given the surface area of A and the volume of A. Figure out the surface area and the volume of B. Take a second and try that out. It shouldn't be so tough. We got something. Yes, ma'am.
So does it not really matter?
No. Nope. None of these. We could get more. We can get a lot crazier on this if we really wanted to, because then we can find scale factor and then figure out a part of the problem and make this really, really nasty. But what's that? Surface area and volume of figure B. The one that's it. We've got surface area volume of A. But excuse me. Did you get that far at least? Okay. And then it's just a matter of setting it up. 154 to something. 64 to something else. What's wrong, Sophie? Don't have to apologize. Yep. Yep, it's just a matter of cross multiplying and solving here. It's really nice when one of the values is 1. Not much math to have to do here. Okay. So one of them, you get a surface area of something that ends in a 4. I don't know what the first one is. 1064? 2464. So this one is 2464 units were square feet. And then this one was it 4096? 1096, that was close. 4096. again, it's just a matter at this point pressing some buttons. Now, will any of this, notice we started with scale factor and worked our way up. Will this change at all if we start with volume and work our way backwards? No, instead of squaring and cubing, you're going to be taking cube roots first and then squaring. Right? Let me show you what I mean. If you start with two similar figures, A to B,